Thank you, Robert, and it's my pleasure to be here. This is my first time in the country of Singapore, and it's wonderful. I'm staying at the Sands Marina Bay, and I think my room is about the same size as this auditorium. I asked Aloysius if we could actually have this presentation at the pool this morning, but he wouldn't let me do that. But maybe we can do something next time like that. I am here to talk a lot about securing what the next generation of IT is, but I think it's also important to sort of understand how significant cloud computing can promise to be. As you'll see in some of my presentation, I feel that for all of the effort and all of the work and all of the industry that's been built to get to where we are today in information technology, all businesses, all IT companies, all countries are essentially back to the same starting point. And we all have a lot of opportunity to shape what the future is going to be. And the mind share and the business of global enterprises IT is really up for grabs. And hopefully I'll explain that in a way that will get you excited to move more quickly in the cloud space and to do this in a secure and responsible fashion. So, but I've noticed the iconic image from the movie 2001 Space Odyssey, where the ape actually sort of discovers tools as weapons, and how that led to all the other development you saw in spaceships and everything else. I actually think we're at that same sort of a major disruptive point in history, where we have something that it seems like we hear about cloud all the time, and it seems like it might be overhyped and we hear too much, and it's just going to be another one of those trends that becomes yesterday's news. But in fact, I think this is actually a generational shift in technology where compute becomes a utility. And I'll tell you, the IT seems like it's going to get changed completely. But actually what I think is going to happen is when we look back at this 10 years from now, we're going to say, IT was probably the least changed thing, and it was everything else. It was every industry got completely disrupted and changed. You've probably heard the story. There's been several of the different anecdotes, like Eli Lilly, where a single researcher was trying to do new drug research, and they needed a lot of compute power in order to do this. And the internal IT department said, we can do that for you. It's going to take 3 months and several $100,000 to be able to get you all the compute power you need to do that, all the number crunching. And of course, the cost for new drugs, for blockbuster drugs, the cost of time is what's really important. You know, it's I think $150 a minute or something crazy like that. So that one researcher went to Amazon, AWS, credit card in hand, and completed that entire project in 4 hours for $89. And the important things is there's a lot of those stories out there. The important thing isn't that, in fact, a major multinational company could prove that it could save several $100,000, or even that it was able to do things more quickly, which is actually a bigger deal than the cost savings. But one person proved that they didn't need Eli Lilly. They didn't need that major multinational company behind them. They were able to do that by themselves. And you think about what that enabling capability, that liberation is going to mean to people who have good ideas, and it's going to extend far beyond IT. So think about that a little. Think about how that might reshape any industry that's out there. So I do think it's very important to go through definitional things as well. I think one of the most important misconceptions that happens in the world today is that it's the cloud, and it's not the cloud. It's many different types of clouds that are out there, different types of services that can be produced and delivered in many different ways. I do think that this utility represents probably the third generation of compute after mainframe and client server, and it's really what I would call the next version of the internet, where the internet was originally deployed to connect the world, so we can connect everything together. Now we're leveraging that connection to actually optimize the utility of computing and put things where they belong. When we think about, and I'm going to make some predictions about where we're going in the future, I'm going to be referring back to what I think some of the key enabling factors are. So it's important for you to sort of get with me on this and what I'm talking about. So what are those four enabling factors that I see? Moore's Law, I think, is a fundamental thing that continues to happen. The price performance increases in compute are rapidly bringing the costs of raw storage and compute down to practically nothing. And that's going to mean that over time, when you look at if we are going to continue to have this concentration of IT assets in major data centers to deliver cloud services, that the variable cost that we're going to be dealing with in the long term is going to be the cost of energy. Basically, cost of cloud services should be the cost of energy. Hyperconnectivity, or the ability, the bandwidth investments that we've made over the past dozen years, that's a key enabling factor. That is what is allowing us to put compute resources where we think they make the most sense and not having them being forced to be inside of any enterprise's corporate walls. Because we have the ability, because we have enough bandwidth to efficiently run applications, we have the luxury to put resources where they need to be. Still not good enough. You probably are aware of that one of the major ways of transporting databases between major cloud centers is DHL, Federal Express, UPS, where they actually take hard drives and they ship them, because we still have a lot of work to do with them, but we're getting there. Service-oriented architecture, so this is something that people don't always think about a lot, but the transformation in how applications can work and integrate with basically self-describing protocols, instead of having middleware that must be integrated and compiled into things, that's allowed the explosion of mashups and the explosion of being able to leverage in an object-oriented fashion other computing innovations that have happened before. And that's a key thing to drive not only the pace, the speed with which applications are delivered and that agility, but it also increases all sorts of choices of what we are able to do with different software and how we can reuse it. So it's very significant, and I think it's going to continue to grow. And I think when we talk about future things, I'm going to challenge maybe some of the conventional thinking on how much concentration of assets we're going to be actually doing when we have the ability to connect so freely between different resources. And then the other big thing, the fourth major factor, is the scale that cloud providers, can do with what they have learned. A lot of the cloud computing providers have come from the internet, e-commerce spaces. While a large enterprise may have 100,000 employees, 200,000 devices, that requires a lot of scale and very good processes. But when you compare that to cloud providers who have hundreds of millions of users, and maybe they need to have agent software on devices all over the world, they understand scale and have developed processes to deliver those services and provision and manage those services way beyond what enterprises can do or can ever hope to do, I think. And that gulf, that efficiency gulf, is only going to get larger. So understanding those factors, and this graphic that I basically copied out of NIST, we used the NIST definition at Cloud Security Alliance. It was actually not published when we started, and we had a lot of good conversations with them as this was being developed, and it aligned very well with what we were doing internally, so we felt it made a lot of sense to embrace what they're doing. But we think of, in terms of the delivery of the cloud computing, we think of it as three main categories of services. Infrastructure as a service, which is this raw compute and storage, fairly simple. Platform as a service, which you characterize as a rapid application development environment. And software as a service, which builds on top of that and provides the full business application. Now, this can be deployed as a public cloud, which is probably when most people think about cloud, that's what they think about. But also can be deployed as a private cloud, where you actually do have some parameters around that cloud. And it can be a hybrid, and I think that's the most common thing, as I'll talk about that a little bit. That will be delivered. You will have any sophisticated enterprise is going to use many clouds, and it's very important that they integrate with each other. And that's a lot of the security challenge, frankly, is it's multi-vendor, it's multi-tenanted, it's multi-everything, and we've got to figure out common strategies to secure that. So there's another, this is an eye chart, and the reason I put this up, it's a very interesting graphic, and it forces you to go to our website and download our guidance so you can read it, actually. But we like to look at software as a service, platform as a service, and infrastructure as a service as a layered OSI model type. That's what our cloud reference framework does. And OSI was fundamental. Understanding the OSI model, even though the protocol behind it was not what became predominant, and it was TCP/IP. Understanding the OSI model is what made enterprise networking possible. It helped us understand the differences between bridges and routers and gateways depending on which layer those protocols resided on that 7-layer model. In the same way, we think it's very important, although you could say it's an abstraction of reality, maybe not reality itself, to understand cloud computing in that same layered model. For example, an organization, a company like Amazon.com is commonly thought of as infrastructure as a service, providing this raw compute and storage, but actually they deliver a lot of other services on top of that. Microsoft Azure is commonly thought of as platform as a service, but there are certain elements that are delivered that actually look a little more like infrastructure as a service. And the key thing as we move forward is to understand that there will be companies and entrepreneurs that reside in one specific layer of this model. Cloud intermediaries, cloud brokering, that's going to exist in one area here. Because again, we know this complexity to deliver these services, complexity can breed insecurity, and that becomes a lot of the challenge here. But it's very important that you think about it in this layered fashion and understand anything that is software as a service today that seems as though it's a self-contained company is going to have to migrate due to the economics that are driving this whole infrastructure. They will either have to reside on top of a common infrastructure as a service provider, or they're going to need to be so efficient that they can compete and they can actually deliver that infrastructure themselves. And Salesforce.com is a good example of that. Started as software as a service, but their platform as a service that they used and their efficiency there became good enough that they actually deliver that as a separate for-fee service. So what does it look like for the next 3 or 4 years? What picture do we paint? What are the challenges ahead? We have this notional understanding of our organization, but our information boundary actually extends way beyond that. And the thing I want to introduce here, although we try to stay very focused on cloud computing, we cannot analyze and secure this new trend in an island, in isolation of everything else. And so it's very important for us to understand the trend of mobility, and this being the year that smartphones and tablets exceed total worldwide shipments of PCs. A lot of these devices are going to be entering into the enterprise, and so it's very important to understand, what does that mean? It means we're going to have cloud services that enterprises use, and we're going to have such mobility that we will have all sorts of business that is conducted end-to-end without ever being in our enterprise. And we have this full dispersal of applications and data and users and devices that it's really driving some big challenges from a security perspective. What I see is as we have this dispersal of everything, as we have this separation between the data owners, the cloud customers, and the data processors, the cloud providers, as we understand some nuances between traditional outsourcing, the anonymity of where providers are, the anonymity of the geography, the very quick changes, the very dynamic nature that creates a very transient sort of business relationship, machine to machine, that lasts so many seconds, that we need to throw out our physical security controls, and we need to have virtual controls. And we need to design things from the ground up. So any of you who follow the big security threats that happen in the news, the advanced persistent threats that take down or infiltrate even the most secure organizations, we know that existing perimeter-based security has been dead for a long time. And what's very important is from the ground up, we create an entirely new virtual control regimen, which is what we're trying to do. But this is very exciting to me. If you think about how we allocate information security dollars, I think we can be a lot more effective about that. We change, we hit that big reset button for security. So we've done some research and want to highlight what we think some of the security problems are that we see today and what we see coming forward in the future. So through our threat research, it's not a matter of completely new threats. It's understanding that based on this concentration of systems and data, that certain existing threats become more amplified. And the key thing that came out, and I'm paraphrasing a little bit of our research, this is like it's a short read, it's about a 12-page document that you can download from our site, our top threats research. But trust actually has come up as that's the number one threat right now, because we have a lack of provider transparency, and that creates real issues in us understanding what is that provider doing, how does that map with my own risk tolerance, my own compliance requirements, the own governance that I have to do, because although they have my assets, I still have a legal responsibility for them. And this is something that is fundamental, and you'll see through a lot of the research, that became our near-term sort of our tactical, we got to solve this problem now. I think we've made a lot of headway there. Data, which is closely related, came up as our second issue, that basically having an inability to really clearly understand where that information may reside and understand all issues from, is the data going to be securely deleted, completely wiped if we change our relationships and we move to different cloud providers? Can we understand how it might be commingled with potentially some of our competitors? Do we understand the jurisdiction that information may be in? Maybe we have a relationship that says that our data is going to be stored at a certain data center. Well, do we really understand for example, the disaster recovery, the business continuity planning issues within that cloud provider, and do they maybe create some redundancy hot sites, sorts of activities, or online backups that actually send your information into another data center that's not in your SLA or your contract? So when I talked about how exciting that is, and I talked about agility, and there's a lot of stories I could tell you about companies that are using cloud to change their product development cycle from months to days or weeks. But there's a downside to that, and that's that we can expect to see a fair amount of insecure cloud software, because we don't manufacture software like we build planes. We know that. We don't even manufacture software like we build bicycles, unfortunately. So we can expect that the vulnerabilities are going to continue to be a problem, going to continue to be with us. So a few others here I'm not going to go into a great amount of detail on, but we do think that cloud, because it has so many, you have such easy ability to scale it, and you have so much compute on demand, and we know that malicious actors, they have a lot of stolen credit cards, they have a lot of ability to access this, that the idea of super botnets, they're inhabiting clouds, the ability to have malicious actors that are sort of co-located next to you in a different in the same data center. Those are things that we're concerned about. None of these issues are things that should be inhibitors to you adopting cloud or stop you in any way. The reason is because you don't really have a choice. It's a question of when you need to do this. And there are solutions for these things. It's a matter of moving judiciously with appropriate risk management. So where are some of the key problems that we're seeing tomorrow as more organizations adopt cloud? And one, and I'll talk a little bit more towards the end about features, is changes. We're moving into a change cycle with software as a service, infrastructure as a service, that's way beyond what we're used to. We're used to Patch Tuesday, right? And we're used to maybe quarterly updates of applications, and now we're talking about things continuously being updated by developers. And new features added all the time, new changes. Because they only have one place now they need to update. They don't have 10 million different instances of their software running anymore. So that paradigm itself is something I don't think we've really come to grips with. The ability for cloud to actually be efficient and effective relates a lot to economics. And actually that's one of the things that I'm very interested, if there's an economist here, that's an area that I'm looking for good economists to look at security and trust from that perspective. But what is going to be the biggest barrier to the global economics that make cloud efficient are globally incompatible policies and a lot of jurisdictional issues that force us to do way too much redundancy and say, we have to have a data center in every country because of that country's laws, or even in every state or every county within those states. That is going to kill cloud, and I don't think it's going to kill cloud because I think we're going to see so much activities around it that we are actually a great opportunity to create some harmonization of public policy on a global scale. Standards are certainly an issue. We're in, to a degree, and it's sometimes used, I think it's overused as a objection to go to the cloud. We'll wait for the standards. And there's a lot of standards. There's probably 100 different standards that relate to cloud that are out there. What we need to do is come up with good reference architectures that use those different standards. I'll give you a few examples of that through the talk. But that's the big issue that a lot of enterprises that are moving to the cloud today, if they don't do it smartly and understand how can I create the right types of principles in my architecture, such as the loose coupling of something like SOA to actually make applications pretty portable between different types of clouds. And it's also a great business opportunity. That whole intermediary space is pretty much virgin territory for new entrepreneurs, and I think we're going to see a lot of companies that provide that. We've seen some of it, and there's going to be a lot more. When I talk about the dynamics here and how quickly things change, and that idea that it's not Patch Tuesday, it's not quarterly updates of software, it's continuous changes, and it's even continuous changes in looking at the different options that an organization might use. They may switch very quickly between different online backup solutions. That while certification is important, and I know a lot of people are probably thinking about that, what are we doing for certification of providers, for example? Something that's important, something we're concerned about. But certification is not going to be enough in this world, and we think it's even more important to have the ability to look at, from a governance, risk management, compliance perspective, to have continuous monitoring of your risks, continuous monitoring of your controls. And that's something we think we need to move with. Identity management is an area that I think is also one of these key issues that we don't do identity management well enough today, because I don't think we have enough of a comprehensive view of it, and we get isolated into an enterprise's view of their identities, maybe a government's view, but a device is a device. A human being is a human being, and they're going to use a lot of different services. They're going to connect to a lot of different systems, and we need to have this holistic view of identity management that extends beyond users to every application, every device, every data store out there, and I'll talk a little bit more about that. And another key problem is the way we respond to issues. Bigger concentration of data, then we're talking about risk concentration. You think about a large enterprise a few years from now that exists to a large degree in the cloud. It's going to be, as I said, many clouds. They'll use many different providers. And a malicious actor that wants to attack a financial institution in the cloud, the symptoms will be attacks of several different providers. And the question will be, are our competitors cooperating in a very agile fashion, a very quick fashion to exchange information and to address those issues very quickly? So I'm not going to go a lot into this slide, but we're here to help. We're very excited to have a Singapore chapter now of Cloud Security Alliance, and the purpose of the chapters will be to help with the global research we do in creating a lot more awareness around that within regions, but even more importantly, to take some of our work and apply that to local projects, such as standards that the Singaporean government may be able to do, or regulations they may be able to do. You can reference a lot of what we're doing. So we're essentially the only really large global organization that's strictly focused on this issue. A lot of individuals, a lot of corporate members, and a lot of research that's ongoing. And I think, as for my introduction, you probably got a little bit what we think our hot buttons are, but they're there: GRC, public policy, identity management, interoperability. That's what it's going to take.